So we'll start with our very first chapter, that is units and measurements. Okay.
Okay.
Can you tell me some basic uh, the concepts that you are aware of, in units and measurements? Like what are the topics that you have studied?
Physical quantities, fundamental quantities,
Yeah,
and units
your voice is not
and
clear, Sahiti.
groups.
Sahiti, some disturbance is coming from your side. Remove the headset and try to speak. Remove the headset, then it will be clear.
Is it audible, ma'am?
Yeah, now it is audible. So what are the concepts that we will study in this chapter, Sahiti?
I have studied physical quantities, errors,
Okay, no, fine. So I
fundamentals, and
yeah, so in this chapter basically we will study about all the physical quantities and the different types of physical quantities and the related problems. We'll study about certain instruments like vernier caliper, screw gauge, and also we'll study about significant figures, errors, all those things. So maximum in 2 classes, if not 3 classes, I'll try to finish this chapter. Okay. And today is our class 1
okay.
related to this unit. So very first thing that you know about, that you have to know about, is physical quantity. What is physical quantity? So any
Excuse
quantity.
me.
Yeah, Sahiti, audible?
Yes.
So any
Yeah,
quantity
ma'am.
which can be measured, any quantity which can be measured is called physical quantity. Okay. And this physical
Okay.
quantity is expressed in two things. It should be having magnitude, and it also must be having unit. So any quantity which has both magnitude and unit, that will be considered as physical quantity. Okay. If there is any doubt, let me know, Sahiti. Okay.
Okay, ma'am.
There are three types of physical quantities basically. Number one, fundamental physical quantities. I'll write it as PQ. Derived physical quantities and supplementary physical quantities. First, we'll discuss about fundamental physical quantities. What are these fundamental physical quantities? These are fundamental, that means very basic. If you want to study any kind of phenomena happening in the nature, these are the basic quantities that are required. For suppose I have traveled 11 kilometers from my office to home. 11 kilometers. It's a basic thing. It's a distance. Now distance is a fundamental physical quantity. Okay, so fundamental
Okay.
physical quantities are the basic physical quantities. Okay, these are the minimum required quantities to explain any phenomena happening in the nature. Okay, and there are
Okay.
7 fundamental physical quantities. Those are mass, length, time, electric current, temperature, amount of the substance, luminous intensity. So these are the 7 fundamental physical quantities. Memorize them, Sahiti, now itself.
Okay. Okay, ma'am.
Okay. Now, what are derived physical quantities? Those quantities which are dependent on fundamental quantities. So I can say derived physical quantities are The combination of fundamental quantities. Combination of fundamental
fundamental.
physical quantities. For suppose I just say velocity. What is velocity, Sahiti?
Velocity is distance
Displacement.
by time taken. Yeah,
Displacement by time.
displacement.
So displacement in the sense again distance, again time. So I can say distance as length, time as t, L by t. So you are expressing velocity in terms of distance, that is length, and in terms of time. Now length and time are fundamental quantities, right? So
Yeah.
velocity is a derived physical quantity because it is depending on two fundamental physical quantities. Okay. So if any physical quantity
Okay.
is expressed as a combination of fundamental quantities, then that is a derived physical quantities. See, if you take time, if you write the formula for time,
Okay.
there is no other quantity on which it depends. Time is the ultimate fundamental quantity. That is the simplest fundamental quantity. But when you take velocity, it is not the simplest one. It again depends on length. It again depends on time. So which depends on fundamental quantities, those are derived quantities. Okay. Now you can take the other
Okay.
examples as well. Like for suppose if I take force, what is force formula? Force is mass into acceleration. So mass is what? A fundamental physical quantity. And what is acceleration? Acceleration is velocity by time. Velocity by time. So mass into what is velocity? Distance by time. And one more time in the denominator. So I can write finally the formula for force as mass into x by t square. Can I write like this?
Yeah.
Force is mass into acceleration. Mass is m. What is acceleration formula? This is velocity by time. What is velocity formula? Distance by time.
Yes.
So if you take the whole formula for force now, it is depending on mass, it is depending on distance, divided by it is depending on square of the time period. So which is a derived
Yes.
physical quantity here, Sahiti?
Acceleration.
Acceleration is a derived physical quantity. Force is also a derived physical quantity. And what about mass? It is a fundamental physical quantity.
Fundamental.
Clear?
Yeah, ma'am.
Now, the third category of physical quantities, which is supplementary physical quantities. What are these basically? They deal with angular part. Like when we talk about momentum, there are two
Okay.
categories: linear momentum, angular momentum. So, angular part, angle related studies will be done in supplementary physical quantities. Okay. So, they deal with what? They deal with angular
Okay.
physical quantities. And there are two angles that we have to study. Number one, plane angle. Number two,
Ma'am, your voice is.
voice is not clear. What about now?
Yeah.
Is it
It's
clear
good.
now?
It's good.
Okay. Actually, from your end,
Yeah.
I'm not listening properly. Your voice is breaking. Okay, no issue. Whenever there is a problem, let me know, Sahiti. Okay. First, we'll see about
Okay.
what? Plane angle. So, what is the difference basically between plane angle and solid angle? Both are angles, but plane angle is considered for two dimensional figures and solid angle is considered for three dimensional figures. For suppose if I take a circle, it's a two dimensional figure. When I take a cone, it's a three dimensional figure. We just consider the angular part in two dimensional figures. There we call it as plane angle. If we consider three dimensional figures, we call it as solid angle. Okay. First we'll discuss about
Okay.
plane angle. What is plane angle? Basically, it is angle subtended by an arc. For suppose I'll just take the center of the circle like this. Now what do we call the distance from center to any point on the circle, Sahiti?
Radius.
Radius. So this is r. Now what about this part? This is also what? This is also the radius, right? Now, so
Yeah.
if you take this portion, a part of the circle, what do we call this? This is called arc. Okay. Now this small part of the circle is making some angle at the center of the circle. What is this angle called? This angle is theta, which is a symbol for plane angle. Okay.
Okay.
So plane angle formula, theta is equals to arc by radius. This is the formula for plane angle. How much is the arc distance and how much is the radius distance? Okay. And what are the units of this plane angle? Its units are radians. It is measured in radius. 30 radians, 40 radians. The unit of this plane angle is radius. Clear? Any doubt in this, Sahiti?
No, ma'am.
Okay. Generally,
It's
arc
clear.
is denoted by L letter, radius is R letter. So if you write the formula for theta, it is L by R. L is length of the arc, R is radius. Okay. Now we'll see solid angle. As I told you, the solid angle is the angle considered for what kind of figures? Three-dimensional figures. It is a 3D angle. First,
Yes.
suppose let me take a three-dimensional figure cone. Let me take a piece like this, okay?
Okay.
Now this piece having four vertex points. This is A, this is B, this is B, I mean C, this is D. 4 points. Let me take the center of this cone. So if I try to connect these 4 points, now it forms a three-dimensional figure, okay? Now this small part
Yeah.
is making certain angle at the center. This angle is omega, which is a symbol for solid angle. You must read this symbol as omega.
Okay.
Omega is the symbol for solid angle. Same is a symbol for
Yes, ma'am.
resistance, right? Resistance symbol omega is also the same.
Yeah.
Same is a symbol for solid angle. Now if I take a very small portion of area here, which is very small dA, then the very small radius r, what will be the formula for solid angle beta? The area that is considered by square of the radius. Its formula is area by square of the
Very
radius.
nice.
Area of the very small three-dimensional figure that we have considered divided by radius square. Okay.
Okay, ma'am.
Now one more concept, like if you take a cone, this is your cone, okay? This is the bottom portion of the cone. The bottom portion of the cone is in which form? Circular form.
Yeah.
The front view of the cone is in triangular form. Front view is like triangle, bottom view is in the form of a circle, right? Now if you
Yes,
take
ma'am.
the center of the circle, that is bottom point, and if you take the apex part of the triangle, if you take this, this is called height of the cone. Now if you take the angle between height of the cone and sides of the cone beta, this angle is alpha. What is alpha here? It is called as semi vertex angle. This is called semi vertex angle. Vertex means corner point. If you take the whole angle
Okay.
at corner, it is vertex angle, but we are taking only half of the vertex angle, right?
Yes, ma'am.
This is the whole vertex angle, we are just taking only half of it, so this is semi vertex angle. Okay.
Okay.
Now where will be our omega? This is a three-dimensional figure. So if I take the whole angle with respect to some area, I'll just consider some portion of the area here, then the whole angle is what? Whole angle is omega. What is this omega?
Yes.
This is solid angle. This formula is important. Relation between solid angle and semi-vertex angle. What is the relation between both of them is omega is equals to 2 pi into 1 minus cos alpha. Relation between solid angle omega and semi-vertex angle alpha. Omega is equals to 2 pi into 1 minus cos alpha. In exam, they will give you semi-vertex angle is 30. Find the solid angle in the cone. Then you have to use this formula.
Okay.
Okay, any doubt so far?
No, ma'am.
No. So clear with the three quantities, physical quantities, fundamental
Yeah,
physical
ma'am. Clear.
quantities, derived physical quantities, supplementary physical
Subject.
quantities. Now we'll go with basic notations, because in the problems we'll see some letters like M, L, T, such kind of things. So you have to be familiar with basic notations. What are the seven
Okay.
fundamental physical quantities? Tell me, Sahiti. Mass,
Length, mass,
length,
time,
very good, time,
electricity, current,
electricity means current,
temperature,
temperature,
amount of mass,
amount of the substance. Amount of
and
mass means mass only, again amount of the substance.
amount of substance, and luminous intensity.
And luminous intensity. Now in problems, what are the symbols that we use for these seven fundamental quantities is the basic notation. Basic notation means symbols that we use for them. Okay, for mass we
Okay.
use capital M. For length we use capital length, distance, all mean the same. For time we use capital T. See, temperature is also T, time is also T, temperature is also T, so there will be a confusion. So what we'll do for temperature is we will take theta. in
Okay.
in in textbooks, no, they'll keep capital K also. Capital K means Kelvin. You can use any one, but I prefer you to use theta, because K
Okay.
is also the symbol for Boltzmann constant. You will be studying in states of matter. So
Yes.
there it becomes confusion. So better you remember theta for temperature. And current, it is capital A. Current unit is ampere. So A is taken as a symbol. Amount of the substance, mole is the unit, we will take MOL. And luminous intensity, candela is the unit, we'll just take C and D. These are the
Okay.
basic notations. Clear?
Yeah, ma'am.
Try to memorize all this.
Finish, ma'am.
Finished. Now we'll see the concept dimensional formula. So what is this dimensional formula? Basically, it is a representation. It is a representation of a physical quantity, any physical quantity, let it be fundamental, let it be supplementary, let it be derived, any physical quantity. We just represent it in terms of its basic notations. In terms of
Okay.
basic notations is called dimensional formula. Short form D dot F, dimensional formula. So what we have to do is, Sahiti, we have to take a given physical quantity, we have to write it in terms of basic notations. What are the basic notations? These are the basic notations in terms of symbols. Okay, for
Okay.
suppose, can you tell me the formula for velocity?
Distance by time taken.
So
X by T.
velocity is nothing but distance by time, right? So distance, what is
Yeah.
the fundamental basic notation for it?
Length.
Length means capital L. What is the basic notation of time?
T. Capital T.
Capital T. So bring the T to the numerator, what will you get? Here it
Minus
is
1.
T power 1. If it
Yes.
gets to numerator, T power minus 1. Now keep this in square brackets. Now this is your dimensional formula.
Okay, ma'am.
Okay, so you are representing what? You are representing a physical quantity in terms of its basic notations, and you are enclosing them in square brackets. That is called dimensional formula. Understood?
Okay, ma'am.
Now, can you tell me the dimensional formula? Take your rough notebook now. Take your rough notebook. Try to find the dimensional formula of
Yes.
acceleration. What is acceleration formula, Sahiti?
Uh, well,
Velocity by time. Okay.
yeah,
Keep this time as it is. What is the formula for velocity? Distance by time. So can I write acceleration formula as directly distance by t square?
yeah, ma'am.
Directly remember, acceleration formula is distance by t square. Okay. Now what is distance notation? L. What is t square? Time t, t square. So L t power minus 2 in square bracket. So this is the dimensional formula for acceleration.
Okay, ma'am.
Now, similarly, we will do for work. What is work formula? Work is nothing but force into displacement,
Acceleration.
not acceleration. Force into displacement. Force is capital F, displacement is distance d. Now, what is force formula again? It is mass into acceleration. What is acceleration again? Distance by time square. So I can write it as mass into distance by time square into distance. So what is the final formula? M into d square divided by t square, right?
Yeah, ma'am.
Any doubt so far, Sahiti? Sahiti,
No,
no,
ma'am,
no
clear.
issue even if you are having zero preparation. Whatever I'm telling you now, each and every class, take it serious. No issue if you don't know the answer. Learn it today after the class. Whatever I'm telling you, learn them. If you just learn
Okay,
whatever I'm
ma'am.
explaining in your 3 months courses now, definitely you will get 80% of the marks in physics.
Okay, ma'am.
Okay, so m into d square by t square. Now what is m here? M is a mass, d means length, so l square divided by t means time, t square. So what will be the final dimensional formula for work? It is m l square t power
That's
minus 2.
next.
Clear?
Yeah, ma'am.
Now, kinetic energy. What is kinetic energy formula? This is half into mv square. See, for numbers, we don't have any dimensional formula, right? For number, there is no symbol. For mass, there is a symbol. So, whenever you have numbers, no need to consider them. Okay. Mass is
Okay.
m, velocity, distance by time. It is v square. So, d square by t square. What will you get now? M into d square
Else.
by t square. So it is m l square. Can I write directly t power minus 2?
Yeah.
So this is the dimensional formula for kinetic energy. Now you just observe one thing. Our previous example was dimensional formula of work, which was ml square t power minus 2. Present question is energy. That is also what? Ml square t power minus 2. So here you need to understand a note point. Energy dimensional formulas and work dimensional formula will be same.
Okay.
Clear? Both have same df, dimensional formula. Any kind of energy,
Oh,
potential energy, any kind of energy, energy, work, both will have same dimensional formula. Now next important
okay,
one,
ma'am.
power. What is power? Power is nothing but work by time. So already
Okay.
we did the dimensional formula for work. What was it? ml square t power minus 2. Time is t. So what will be the final dimensional formula for power now? ml square t power
And minus one.
minus 1 or minus
Minus
3? Minus 1 or minus 3?
minus
Minus 3. Here it is plus 1, so if it goes to
minus
numerator,
three.
minus 1. So ml square t power minus 3. Okay.
Yeah.
Now, gravitational constant. Where do we get this gravitational constant? In gravitational chapter, force of gravitation is G m1 m2 by r square.
Um,
From this, what is the formula for G? F into r square by m1 m2, right? Sahiti, am I audible to you?
yeah, ma'am, you're audible.
Yeah. So just now we have done for force. What is force? M into A. M means mass m, distance is L, t square. So if it bring it to numerator, it is ml t power minus 2. This is the dimensional formula for force, right? Just substitute here.
Yes.
So G dimensional formula is equals to first force, that is ml t power minus 2, and then r square. R is what? Distance between two masses. Distance means L. So L square. M1, M2 are masses. So M1 is also M, M2 is also M. So what will you get? 1M, 1M gets cancelled. So M power minus 1, 1L, 2L. Total it is 3L t power minus 2. So
Yeah,
M
ma'am.
power minus 1, L cube t power minus 2. Clear?
Yes, ma'am. Clear.
So I'll tell you most repeated quantities. You have to remember them directly. Okay.
Okay.
So first thing is acceleration, directly L by t square. Velocity, which is directly L by t. Force, ml t power minus 2. Work, energy, both have same, that is ml square t power minus 2. You can remember easily. Work is ml square. For force, everything is same, just L power 1.
Okay.
Just L power 1. Now when you take pressure, it is ml square t power minus 3. You just remember the work formula. If you keep L power 1, it becomes force. In the work formula, if you keep T power minus 3, it becomes pressure.
Okay.
Sorry, not pressure, power, sorry. Clear?
Yeah, ma'am. Clear.
So remember this now. First remember the work formula, ml square T power minus 2. Same work formula, just keep only L. It becomes F. Same work formula, you just keep T power minus 3, it becomes power.
Okay, ma'am.
Memorize these now, and if it is done, let me know.
Done, ma'am.
Done. Can you tell me the dimensional formula for work?
ml square t power minus 2.
Very good. What is the dimensional formula for force?
ml t power minus 2.
Mm. What is the dimensional formula for power?
ml square t power minus 3.
Acceleration?
Uh, lt square.
L by t
lt
square.
minus 2.
LT minus 2 or L by t square. Okay. Now,
Yeah.
so that is all about dimensional formula. You are representing physical quantity in terms of basic notations. Now, what are dimensions? Have you noticed, Sahiti, in each dimensional formula we are having some powers like m power 1, L power 2, t power minus 2. We are writing it down in terms of some powers, right? So
Yeah.
those powers are called dimensions. So powers of the physical quantities, powers of the physical quantities in dimensional formula, in their dimensional formula are called dimensions. So you just have to write the dimensional formula and you just have to notice the power. Those powers are called what? Those powers are called dimensions. See, simply I can ask you what is the dimension of time in power formula. What is the dimension? Minus 3. Power is nothing but dimension. Okay.
Okay, ma'am.
Are you clear with so far basic part?
Yeah, ma'am. Clear.
Now we'll discuss previous year questions from your NEET exam. Okay.
Okay.
Till 2020, what are all the previous questions are given from the concepts that we have discussed, we will solve and then we'll go to next topic. Okay, we'll discuss topic
Okay.
previous year questions. Now see this first question, dimensional formula of stress is. What is stress? Basically stress is also a kind of pressure, right?
Yeah.
What is pressure formula? It is force by area.
Yeah.
What is force dimensional form? You have to find the dimensional formula here. So what is force dimensional formula?
ml square t power minus 2.
ml square or L?
L square.
ml square t power minus 2 is work. ml t power
L
minus 2
square.
is force. Okay.
Yeah.
Area, what is area actually? Area unit is what? Meter square. 2
L
meters,
square.
L square. Okay, so simplify this. So 1L gets cancelled, so you'll get m t power minus 2 divided by L. So what is the final answer? M L power minus 1 t power minus 2. Where is our answer? Option C.
Yeah.
See, very simple questions are asked in NEET exam from this chapter, Sahiti. The only thing is you have to be very clear with the formulas. That's it. You have to
Okay.
substitute formula, substitute the notation. Answer is very easy. Okay. One more
Okay.
previous year question from your NEET paper. The pair of quantities having same dimensions. See, when do you have the same dimensions? If they are having same dimensional formula, right?
Yeah.
When dimensional formula is same, if they are having same general formula, isn't it?
Yes.
So let us check. You have, what is the question here? You have to find which two are having same dimensions. Let us do it one by one. First, take the first option, Young's modulus and energy. Young's modulus is also a kind of stress. It is also a kind of pressure. Just now we have
Okay.
done for pressure. What was the pressure stress? It is ml minus 1 t minus 2, right? No
Yeah.
need to do again. We'll just take the same ml minus 1 t minus 2. And what is energy? I told you energy units, work units are same. What is work units? ml square t power minus 2. Energy,
Okay.
work, both are having same units. Now see,
Yeah.
do they have same units here? M is same, t power minus 2 is same, but that is L minus 1, that is L square. So this is not our
Yes.
answer. Here L minus 1, here L square. They are asking same dimensions. Here length
Yeah.
dimensions are not same. Clear?
Okay, ma'am. Yeah.
Now take the second one. Impulse. What is impulse? It is nothing but change in momentum.
Okay, ma'am.
That means mass into change in velocity. What is mass dimensional formula? M. What is velocity dimensional formula? L by T. So you'll get m L T power minus 1. Right?
Yeah.
Now what is surface tension, Sahiti? Surface tension is a force,
4 square.
yeah, force per unit length. So force, I told you the dimensional formula. What is the dimensional formula for force?
ML T power minus 2.
ml t power minus 2 divided by what is L? L is length. So what is the final formula now here? L gets cancelled. So this
ML
is
T.
mt minus 2. Now do they have the same dimensional formula, impulse and surface tension?
No, ma'am.
No. So this is also not our answer. Okay.
Okay.
Now angular momentum and work. What is angular momentum? Linear
Yes.
momentum is m into v. What is
MVL.
very good? Angular momentum is m into v into r. M is mass, velocity is distance by time, r is radius, that means L again. What is the
Length.
dimensional formula now? ml square t power minus 1, right? Now work, what is work unit, society? Work dimensional formula? ml square t power
ML
minus 2.
square T power minus 2.
Yeah. Now see here, do they have the same dimensions? M is same, L is same, but T dimensions are not same. Here it is minus 1, here it is minus 2. So this is
Yes.
also not our answer. Then what is the answer here? Work and torque.
4.
This is our final answer. So what is the,
Okay.
if you verify fourth option, work dimensional formula already we have studied, ml square t power minus 2. Now let us take torque. What is this torque? It is a force which is acting perpendicularly. So
Yeah.
we just take perpendicular distance into F. F into R is a formula for torque. So force
Yeah.
is what? ml t power minus 2. And R is a perpendicular distance. That means L again. So what is the final dimensional formula? ml square t power minus 2. So same dimensions for mass, length and time.
Okay.
So what is the final answer now? Option D is the final answer.
Yes.
Okay, so this was also one of your previous year question. Now see
Okay.
another previous year question. The dimensions of mu naught epsilon naught whole power what? Minus 1 by 2. Sahiti, can I write x power 1 by 2 as root x?
Yeah, ma'am.
What about x power minus 1 by 2? I'll write it as 1 by x power 1 by 2.
Yes.
Numerator minus means in the denominator it becomes positive, right?
Yes.
Now the same thing, can I write it as 1 by root x?
Yeah, ma'am. You can
1,
write.
1 by 2 means root. Minus means in the denominator. Okay. Now see this question, the same was given mu naught epsilon naught power minus 1 by 2. So I can write it as 1 by, because minus 1 by 2, so square root mu naught epsilon naught. What is this mu naught?
You're not permittivity of.
It is permeability. You will study in magnetism, permeability of free space.
Okay, ma'am.
Okay. Epsilon naught is permittivity, which you will study in electricity. Permeability
Yes.
is related to magnetic fields, permittivity is related to electrical fields. So this is permittivity of free space. Now they are asking you the dimensions of this 1 by under root of mu naught and epsilon naught. This is Sahiti actually the direct formula for what? Speed of an electromagnetic wave. C means
Oh,
speed. This is directly the formula for speed of an electromagnetic wave. So speed is nothing but velocity. So what are the dimensional formula of velocity? Speed is nothing but distance by time. So L by
hello.
t. That means L t power
Yes.
minus 1. This whole formula, this whole given quantity represents velocity of an electromagnetic wave. So velocity
Yeah.
dimension formula is what? L t power minus 1. So answer is option B.
Okay.
See, very simple. It looks difficult, but it is very easy.
Okay.
Any doubt so far?
No, ma'am. Clear.
Related to basic notations, and you have to study about dimensional formula. Based on just this one topic, we are having 3 questions in previous year papers of your NEET exam. Okay.
Okay, ma'am.
Now we'll see principle of homogeneity. Homogeneity means the same beta. What do we consider same here? Related to this chapter, what do we consider same? We just consider dimensions. Dimensions of a physical quantities on LHS side equal to RHS side. This is what we consider here. Okay.
Yeah.
We'll consider some important points here. This is the first important point. Dimensionally, physical quantity on left side, the same physical quantity on right side, dimensionally they are same. Now second thing what we consider is, you take any sine functions, any cos functions, any logarithmic functions, any exponential functions, all are considered to be dimensionless.
Okay, ma'am.
Dimensionless means they do not have any dimensions. That means m power 0, l power also 0, t power also 0.
Okay, ma'am.
Okay. Now dimensionless, everything power 0. What does it mean? For suppose I have exponential of ab. Now what do I say? Exponential function is given. That means this is dimensionless, isn't it?
Yes.
So dimensionless means how do I solve this problem? So dimensionless in the sense you have to consider 2 things here. The whole value of this exponential power of AB will be taken as 1, because it doesn't have any dimensions. Is this point clear? No dimensions. M power 0, L power 0, T power 0. What is the formula power? A power anything? 1, right?
Ma'am, can you repeat once again? Your voice is breaking.
Now am I audible?
Yeah, ma'am.
Okay. What is the meaning of saying dimensionless? Dimensions means what? Powers. If
Yeah,
we say that they are dimensionless, what does it mean basically? They don't have any powers. Dimensionless in the sense m power 0, l power 0, t power 0. They don't have any they don't have any powers. Dimension
yes.
means power. Dimensionless means they don't have any powers. Power is 0.
Okay, ma'am.
So what will be the value if it is dimensionless? It will be 1 beta, because a power anything is 1. You have studied this
Yeah,
in maths. So for example, I'll just take one example, exponential of AB.
yes,
What is the second principle in homogeneity? Exponential values, logarithmic values, cos values, sine values, all are dimensionless. So
yes,
here the example that I have considered is an exponential function. So this is dimensionless, right? So what will be
yeah,
its value? Exponential of AB value, it will be 1.
yeah, ma'am.
Even if I take only AB value, that will also be 1, because that is also a part of exponential function, right?
Yeah,
The
ma'am.
whole expression dimension is 1. The power of exponents is also 1, because it's dimensionless. 0 means 1.
Okay, ma'am.
Is this point clear, Sahiti?
Yeah, ma'am, please.
And one more important point in this, in principle of homogeneity. First principle is dimensionally same on left and right side. Second important principle is sine functions, cos functions, logarithmic functions, exponential functions are dimensionless. That means they don't have any power.
Okay,
And next important things which is important for problem solving, if you take any physical quantities, let it be their addition or let it be their subtraction, addition or subtraction of any two physical quantities is done only if they have same dimensions.
okay, ma'am.
Only if they have same dimensions. If they don't have same dimensions, addition is not possible, subtraction is also not possible. They must have same
Okay,
dimensions, then only we can do these arithmetic operations, either addition or subtraction.
yes.
Clear with this?
Yeah, ma'am, clear.
Go through all the 3 points in principle of homogeneity. Remember them and let me know.
Okay, ma'am, done.
Done. Okay. So let us see previous year questions based on this principle of homogeneity. Okay, these are also questions from your NEET exam, past papers. So see the question here. A, B, C and D are 4 different physical quantities. Okay, fine. Having different dimensions. The 4 physical quantities A, B, C, D are having different dimensions. So can you do addition and subtraction in that case, Sahiti?
Different dimension. No, ma'am.
No. Why? According to principle of homogeneity, third point, addition or subtraction can be done if they have same dimensions. Here different dimensions. So here addition subtraction cannot be done. Is this point clear?
Yeah, ma'am, clear.
None of them is dimensionless. That means if A is also having dimensions, B is also having dimensions, every quantity is having dimensions. Fine. But we know that the equation AD is equals to C logarithm of BD holds true. Fine, some relation is given. Then which of the following combination is not a meaningful quantity? Can you guess the answer, Sahiti?
Yes,
4 quantities are there, A, B, C, D, different dimensions. That means according to principle of homogeneity, you cannot do direct addition, you cannot do direct subtraction. Now which of the options is a wrong one, which is not meaningful, which is not the correct one? First one is C by BD, AD square by C. See, you are doing subtraction but not directly, right? First you are doing b into d, then c by bd, a into d
Yes.
square, then after that you are subtracting. So maybe this is possible. Next
Ma'am,
one.
I did not understood this, ma'am.
Okay, read the question once.
Uh, yes, ma'am.
Okay, what was the question saying, Sahiti? What is the meaning of the first line in the question? Tell me.
A, A, B, C, D are four different physical quantities.
Mm, okay.
Having they have
Mm,
different dimensions.
okay. So from this point, what will you understand? Different dimensions. Go back to principle of homogeneity. Same dimensions, then you can do addition or subtraction.
Yes, ma'am.
In the question, it is saying different dimensions. So can you do a plus b, b plus c, c plus d, a minus b? Can you do such kind of plus and minus?
No, ma'am, we
No.
cannot.
That is the meaning of this first point. The very
Okay.
first line in the question says that a, b, c, d, according to principle of homogeneity, they cannot be added or subtracted directly.
Okay.
That means directly a plus b, directly b minus c, c plus c, c minus d. Direct addition, direct subtraction cannot be done. Cannot be added or subtracted directly. Is this first point clear?
Yeah.
Now, the remaining complete part of the question is given just for making it lengthy. To make it a lengthy question, they have given the remaining part of the question. None of them
Okay.
is dimensionless. None of them is dimensionless. What does it mean? Every physical quantity,
Everything is
a is also having units, b is also having units, c is also having units, d is also having units. None of them is dimensionless. That means a, b, c, d, all of them have dimensions. That is the meaning of it. The
yes.
second part says all have dimensions. Okay. Now,
Okay.
some relation is given. Fine, this relation is holding correct. Fine. Now, what is the main thing that we have to find this question? Which of the following, which of the combination is not a meaningful quantity?
Okay.
There are four combinations given in the question. A, B, C, D. Four combinations are given. Which is not a meaningful one? That means you
Okay.
have to pick the wrong one in the options. You have to pick the wrong one. So
Okay.
how shall we do this? Just based on the first point in the question. Having different dimensions. We'll just apply that first point in the options. See the option A, C by BD minus AD square by C. Do you think A, B, C, D are directly subtracted here, Sahiti? Or first they are doing C by BD, then AD square by C, and then later they are subtracting?
They are not directly subtracted.
Directly, not directly subtracted, right? So this may be possible. A square minus B square into C square may be possible. First you are doing a into a, then b square into c square, and then later you are doing subtraction. So not directly subtracted. Here also not directly subtracted, may be meaningful. See the third one, a by b, first division and then subtraction. So here also not direct subtraction, may be possible. See the d1, a minus c.
First subtract.
So directly subtraction is done here, right? Directly a minus c is done. Are you noticing this, Sahiti?
Yeah, ma'am.
So what should be the case here? They are having different dimensions, so they should not be subtracted directly, but in the fourth option directly they are subtracted.
Yes, ma'am.
So this is not a meaningful one.
Yeah, ma'am.
A and C are having different dimensions, so they should not be directly subtracted.
Okay, ma'am.
Okay, why are you saying this? Because according to principle of homogeneity, direct addition, direct subtraction can be done only if they are having same dimensions.
Okay, ma'am.
Simple Sahiti, you can do 2 meters plus 3 meters, but you cannot do 2 meters plus 5 seconds, right?
Yes, ma'am.
Meters and seconds cannot be added. Meters can be added, meters can be subtracted. Same units, then you
Yeah.
can do addition and subtraction. Different means you can't do it, right?
Yeah, ma'am.
In the question they have said different dimensions, so you cannot do direct addition or subtraction, but option D says A minus C, directly subtraction. So this is not a meaningful one, this is a wrong one.
Okay, ma'am.
This was the previous year question. Clear?
Yeah, ma'am. Clear.
Are you getting the idea how questions are going to come in the NEET exam?
Yes, ma'am.
Clear with this question? Any doubt, let me know.
No, ma'am. Clear.
Okay, now see this fifth question. The force of interaction between two atoms is given by this formula: F is equals to alpha into beta exponential minus x square by alpha kt. Immediately you must recollect the principle of homogeneity. Exponential functions are given. What do we do for them?
Dimensions.
We consider dimensionless. Dimensionless means what? The whole value of
Equal to 1.
exponential minus x square by alpha kt, the whole value will be equal to 1. Also,
Yeah.
which is in the brackets alpha kt, this is also equal to 1. That is the meaning of
Yeah.
dimensionless, isn't it?
Yes, ma'am.
The whole function value is 1, that something in the bracket is also equal to 1.
Yeah,
Is
ma'am.
this point clear? Now,
Yeah, ma'am.
so what is x here? X is a distance, so its dimensional formula is L. K is a Boltzmann constant. Boltzmann constant, what is its dimensional formula? We'll take it from RMS velocity. We have RMS velocity, most probable velocity, average velocity. You have studied in states of matter. Its
Yes.
formula is under root of 3RT by M.
Yeah.
3RT by M. If you take molar mass, let us do one thing. Let us take individual mass. You take mass of one molecule, then it becomes 3 kT by M. 3 kT by M in terms of Boltzmann constant. Here M is mass, T is temperature, and K is a Boltzmann constant. From this we will get the units of K. Let us do squaring on both sides, Sahiti. What will you get? V square is equals to 3 kT by M. Square root and square gets cancelled, right?
Yes.
Now take the subject of K. What will you get? V square into M divided by 3T is equals to K. This is the formula for K, right?
Yeah.
Now write the dimensional formula for K. What will you get? Dimensional formula for K. What will you get? V square. V is velocity. Velocity is distance by time. V square means L square by T square. Will it be fine?
Yeah, ma'am.
Now M is mass, so into capital M, divided by 3 is a number do not have any dimensions. T is a temperature, here I'll take it as theta, because if you take T same symbol we will confuse for time.
O-
So temperature, take theta. So what is the
Okay.
dimensional formula for K now? Mass power 1, length power 2, and time power minus 2, and theta power minus 1. Is this clear, Sahiti?
Yeah.
Any doubt?
Yeah, ma'am. Clear.
Clear. Okay. T is a
No,
temperature.
ma'am.
T is a temperature. So temperature dimensional formula theta. And alpha beta are two constants. Okay, fine. The dimension of B is. So they just gave one formula and they're asking you the dimensional formula for constant beta. So what shall we do now? Again use the principle of homogeneity. First point. Dimensionally LHS will be equal to what? RHS. Dimensionally,
Alright.
LHS will be equal to RHS. Already we did this in this question. Speed of electromagnetic wave. See, we did not take the formula for mu naught. We did not take the formula for epsilon naught. This is d equal to speed. So we just take the same dimensional formula of speed as the answer. That means we know the RHS
Yeah.
part. We know the speed dimensional formula. The same we have applied for LHS also. So this is principle of
Okay, ma'am.
homogeneity, first point. LHS, RHS will be equal, same dimensions.
Okay.
So we'll apply that concept here. Have you understood the question? Sahiti, there is no limit for the class. It's not like only 1 hour. Whatever the topic that is taken for today, it has to be completed, okay?
Okay.
Okay, because very less time is there for you. So I'll take more than 1 hour, okay?
Okay.
Now, so what shall we do? Take the given equation. F is equals to alpha beta exponential of minus x square by alpha kt, right? What will I do? I'll
Yeah.
just take it as into 1 because it is dimensionless. Fine.
Ma'am, can you repeat the question once again?
The force of interaction between two atoms is given as what? With this formula, right?
Yeah, ma'am.
I'm taking the same formula. F is equals to alpha into beta. In the place of exponential function, what am I taking, Sahiti? I'm taking 1.
Okay,
Why,
ma'am.
why am I taking 1? Because exponential functions are dimensionless.
Yes.
That means the whole value is 1.
Yeah, ma'am.
Is this point clear?
Yes, ma'am,
Now,
clear.
see the last part of the question. What we have to find? You have to find the dimensions of B. So
Yes,
from
ma'am.
this formula, take the subject of beta. What will you get? Force by alpha. This is expression 1. So if you
Okay.
substitute the dimensions of F, dimensions of alpha, you'll get the answer.
Okay,
You
ma'am.
know the dimensions of F, that is m l t power minus 2. But do we know the
Yes.
dimensions of alpha?
No, ma'am.
No. So what we have to do is we have to keep this pending for some time. First we have to find the units of alpha. Later we'll substitute in this equation and we will get the answer.
Okay, ma'am.
Okay, so how to find the units of alpha? How will you find the dimensions of alpha? We have one more hint from dimensionless point. The whole exponential value is 1. Also the bracket value is equal to 1.
Yes, ma'am.
Right? So from this take alpha, what will you get? X square is equals to, send this denominator that side, alpha into k into t. Now alpha is what, Sahiti? X square by kt, right?
Yeah, ma'am.
Now substitute here. Alpha is equals to, what is x square? X is nothing but distance. So L
Yes.
square. K is what? Boltzmann constant. Here is the unit dimensional formula of Boltzmann constant. Substitute here. M
Okay.
L square t power minus 2 theta minus 1. Theta minus 1, can I write it as 1 by theta?
Yeah, ma'am.
Theta minus 1. So in the denominator itself, I'll write it as 1 by theta. Now, this is for k. So x square substituted, k substituted, t. What is t here? Is it time or temperature? In the question it was given as temperature. So what will
Yes.
you take now? You will take it as theta. Any doubt so far, Sahiti?
No, ma'am.
No. So what gets cancelled here? Theta, theta cancel. L square cancel. So what will you get for alpha?
And
Denominator m, I'll write it as 1 by t square. So what will be the whole dimensional formula now? M power m power
minus.
m power minus 1 and t square.
Enter.
T power minus 2 means if it goes to numerator plus 2.
Yes.
Clear? Any doubt in this?
No, ma'am. Clear.
They have given f formula. We took this exponential value 1. We have to find for beta. So first we modified and we got this first expression f by alpha. We know f
Okay.
dimensions, we don't know alpha dimensions. How to find alpha dimensions? Bracket value equal to 1. From that, take the formula for alpha and substitute x dimensions, k dimensions, t dimensions. You will get alpha dimensions here.
Okay.
Now substitute alpha dimensions in the first formula. F already substituted. Alpha dimensions m minus 1 t square. M minus
Okay.
1 t square. So what will you get here, Saiti? M already power 1, minus 1 goes to numerator, plus 1. So this is m square L power 1. T already minus 2 is there. Denominator 2 also goes to numerator. So minus 4.
Yes.
So this is the final answer. M square L power 1 T power minus 4. So what is the answer? Which option is the answer? Option C is the answer.
Yeah, ma'am.
Go through this whole question once again.
Okay.
How did we solve this problem? Go through it. Very simple. You have to find the dimensions of B. You have substituted F by alpha formula. You know F dimensions, but you don't know alpha dimensions. For that, you have did all the remaining part of the solution.
Okay, ma'am.
Okay. Now see one more last question. One more previous year question from this concept. The velocity v of a particle at time t is given by v is equals to at plus b by, this is like this beta, v is equals to at plus b by whole denominator t plus c. Now immediately understand, don't read the remaining question. If you are getting any information from the very beginning part, just try to get it. See, denominator t plus c, what does it mean, Sahiti? Addition is done, right?
E equal to C.
When do you do addition? If they are having same dimensions, right?
Yeah.
According to principle of homogeneity, third point, if they have same dimensions, then only you will add, right? What is
Yes.
this t here? T is a time. So you are adding time and some constant c. That means both are having same dimensions. So dimensions of c is nothing but dimensions of time. That is nothing but t.
Yes, ma'am.
Clear?
Yeah,
Where
ma'am.
a,
Clear.
b, c are constants, the dimensions of a, b, c. So c already we got, that is t. Okay.
Yes, ma'am.
Now not lt square, not l, not t square. So directly answer is option A.
Yeah, ma'am.
But we'll do the remaining also. Now, if you take the remaining terms, can I write the expression like at plus b by t now? Can I skip this c? Because even if you add 2 meters, 3 meters, the final unit is meters only.
Yeah, ma'am.
So t plus c, you are adding, both are having same dimensions. So finally they will have same unit only. So you can keep t, you can keep c, it's up to you. Now,
Yes.
this is first term, this is second term. You are doing addition, which means again both are having same dimensions, right?
Yeah, ma'am.
And they are equal to LHS. LHS, what is their velocity is there? What is the dimensions of velocity? L by t. That means the dimensions of AT term is also L by t, B by t term is also L by t. That is why they are added, and that is why it is equal to LHS.
Okay, ma'am.
Getting my point? Right
Yeah,
side,
ma'am.
first you are applying which point of homogeneity? Third point. Again LHS RHS, you are applying first principle of homogeneity. If you take
Yes.
equality symbol, that means LHS dimensions, RHS dimensions are equal.
Okay, ma'am.
Okay. Now we'll take first one. AT dimensions are equal to L by T. A, what is T here? Time. So T, L by T. What is A now? It is L by T square. That
Yeah,
is
ma'am.
L T power minus 2. That is what we got here.
Yeah, ma'am.
Now take B1. So B by T, we'll just continue here. B by T is also having same dimensions L by T. B by T, T is time, L by T. So T gets cancelled. B is equals to what? L. So that is what we got dimensions here.
Yes, ma'am.
No need to do, because A, B, C successively they have given. Last C is given, last C is T. It was not matching with the remaining options. Directly you can
Yes.
take A, but I just want you to know the methodology.
Okay, ma'am.
Any doubt in this question? You have to do practice, Sahiti. Practice only will help you. Only practice
Okay,
will
ma'am.
help you. Okay. Now we'll see the next. Should I give you a break of 5 minutes? Is it okay?
It is okay, ma'am.
Yeah. Because if I take only for 1 hour no Sahiti, I will not be able to complete the syllabus.
Yes, ma'am.
Okay. Unit conversions. What is in my unit conversions here? We'll just take the principle n1 u1 is equals to n2 u2. What is n here? N is nothing but numerical value. And what is u here? U means unit. What you have to understand from this is numerical value will always be inversely proportional to unit value. Simple. I'll give you an example. If you take 1 kg, can you tell me how many grams does it have?
1,000 grams.
1000 grams. Okay. Now, so you have a number here, right? 1 kg, that is n1. You have 1000, which is a number, that is n2. You
Yeah.
have kg1 unit, that is u1. You have another unit gm, that is u2. This is nothing but unit conversion. You are converting SI unit into CGS unit, CGS unit into SI unit. 1 meter is 100 centimeter, 1 kilometer is 1000 meter. What is all this? This is nothing but unit conversion. You are
Okay.
converting SI units into what? CGS unit. And when you are doing
Yes.
that, what is the formula that we get? This is the formula we get. Number into unit is equals to number into unit. N1 U1 is equals
Yes.
to N2 U2. Is this clear? First point.
Yeah, ma'am. Clear.
Now, second point, number value is inversely proportional to unit system. What does it mean? You take this SI system here, Sahiti. Can you tell me which system is bigger, SI system or CGS system?
SI system is big.
SI system is of high priority, CGS system is of low priority, right? Now,
Yeah.
observe the same example in SI system, which is a bigger unit. What is the number value? Very less. Now,
Yes.
gram is a CGS unit, which is a smaller unit. See the number value, it is 1000. Left side
Yes.
1, but right side 1000. So, if you see the relation, number is less, but unit system is big. Number is more,
Yes.
but unit system is small.
Yes,
So,
ma'am.
number value is inversely proportional to unit system. What does it mean
Okay.
is basically is higher the number, that means which system is considered, lower will be the unit system.
Okay, madam.
1000 grams, number is big, grams, but value unit is less. So number
Yes.
numeric value is more, lower system is considered. Clear with this? 1 and 2 points very important. N1 U1 is equals to N2 U2, N is inversely proportional to U.
Okay, ma'am. Clear.
There is one graph question related to this relation. Where is that? Okay, so select the correct graph among all. This is the given question. First graph, U, N, parabola. Then 1 by U, this is N, which is a straight line. Third one. Can you identify the correct graph, Sahiti?
The first one is correct one
Why is it so?
because it is inversely proportional.
Yeah, inversely proportional. N is inversely proportional to U. What does it mean? As the U value increases, N value decreases. If you see the graph
Yeah.
here, when you go to the left side, N value, U value is increasing here. But at the same time, what is happening to N value? It is falling down.
Yes.
So inverse relation means what will be the graph? It will be a rectangular hyperbola.
Yeah.
So this is right answer. At the same time, see the option 2. You are plotting between n and 1 by u. See, u and n, they are inversely proportional. But what is the graph drawn here? 1 by u versus n. Then in that case, you are reversing one parameter, you are reversing one physical quantity, then relation also becomes reverse. Now this time they will have direct relation.
Yes.
If you take straightforward n and u, indirectly proportional. But what are we doing here? We are doing ulta for u. You are
Yeah.
keeping one as it is, you are reversing the other one. In that case, direct relation. So whenever there is a direct relation, graph will be a straight line passing through origin. See, 1 by u value is increasing. Now n value is also increasing.
Yes.
So straight line passing through origin represents direct relation. So this is also correct. What if u is ulta, n is also ulta, then what is their relation? This is the actual relation that we know. If any one
Yeah.
is reversed, relation reverse. Here both are
Yes.
reversed, then relation remains the same. Earlier inversely, now also inversely proportional. If
Yeah,
you do
ma'am.
changes for both, there is no change in relation. If you do changes only in one, then there will be a change in relation.
Okay, ma'am.
Okay, so 1 and 2, both the graphs are correct. Now take this. 1 particle in CGS unit system will be equal to. Particle is CGS unit or SI unit? First of all, particle is a unit of pressure, Sahiti. This
Okay.
is a unit of pressure and particle is a SI unit.
Okay.
Okay, 1 particle is basically 1 Newton per meter square. This is the SI unit of pressure. You can say particle, you can say Newton per meter square, all mean the same. What is the question is, you have to find its value in CGS system.
Okay.
So I can say 1 Newton per meter square in CGS system. In CGS system, what is the unit? Newton becomes dyne, meter square becomes a centimeter square. So you know 1 n1 value,
Yeah.
Newton per meter square u1 value. You don't know n2 value, you know u2 value. SI system 1 Pascal, that
Yes.
is 1 Newton per meter square. CGS system dyne per centimeter square, but we don't know the number there. We don't know the numeric value there.
Okay.
That you have to find. So what shall we do? Do the simplification. 1 Newton per meter square. 1 Newton beta, this is equals to 10 to the power of 5 dynes. And
Okay,
1
ma'am.
meter is equals to how many centimeters? 100 centimeter. Just substitute here. 1 Newton is 10 to the power of 5 dynes. And here a denominator we have 1 meter square. So what will be the
Yeah.
value now? 100 into 100? 10 power 4 centimeter square.
Okay, ma'am.
So what will you get now? 10 power 4, 10 power 4 cancel. You will get 10 power 1 dyne per
Done.
centimeter square. So this is the answer. So what is the value of N2 now? N2 is 10.
Okay,
So
ma'am.
1 particle in CGS system will be equal to what? It will be equal to 10 dyne per centimeter square. This is the answer.
Okay, ma'am.
Now see the next question. Convert 10 newtons. Newton is the unit of what? It is the SI unit of force.
Yeah.
Newton is SI unit of force. Dyne is CGS unit of force.
Okay.
Pascal is unit of pressure. Now,
Okay.
what they're asking is, we have to convert this 10 newtons into a system such that we don't know what was that system, CGS or some other system, we don't know what was that, but some conditions are given. Mass is double this time, length is half this time, and time is double. Mass doubled,
Okay.
time doubled, length is half. So in this case, what we have to find? We have to find the N2 value. We have to find the numerical value.
Okay,
So
ma'am.
what we shall do is, first we have to identify the given thing. 10 newtons. This is basically a force. So what is force dimensional formula, Sahiti? M L power 1 T power minus 2. Right? So you
Yes.
just take 10 newtons. That means dimensional formula. What is it? M L T power minus 2. Okay.
Okay.
That is equals to right side N2. We don't know. But it was given that, see, when do you take equal according to principle of homogeneity? If there are same dimensions, right?
Yes.
Left side also force, right side also force, then only we will equate them. So this time
Yes.
what we have to do is, in the place of mass we have to take 2m. In the
Yes.
place of L we have to take L by 2. In the place of T we have to take 2t. T power minus 2, that means 2t whole power minus 2.
Okay.
Are you getting this point, Sahiti?
Yes, ma'am.
Now, so can I cancel this 2 and 2? Now m into L. 2 power minus 2, what is its value? 2 square is
4,
4.
ma'am. Minus 4, ma'am. Only 4.
2 square is 4. It is 2 power minus 2. So it will be in the denominator 1 by 4.
But if we square it becomes
2,
plus, right?
2 square is 4. You can write it 2 power minus 2, t power minus 2. 2 power minus 2 I can write it as 1 by 2 square. T power minus 2 I can write it as 1 by t square.
Okay, ma'am.
It is not minus 2 whole square. Minus 2 whole square is 4. This
Yeah.
is power, no, Sahiti?
Yes, ma'am.
Did you get the clarity?
Yeah, ma'am.
Minus 2 square. Square negative is positive, but here power itself is negative.
Yes, ma'am.
Any doubt in this?
No, ma'am. Clear.
Okay. Now, so 2 power minus 2. That means first minus you get it denominator. Then 2 square it is 4. Now,
Yes.
t minus is there, so take it in the denominator. Now square is there, so t square. So what will you get? 1 by 4 m l t power minus 2, right?
Yes, ma'am.
Now left side, right side, we have same system of dimensions, mlt square minus 2, mlt power minus 2. So this is,
Yes.
now you just, this is n1, this is u1. Okay, this is all about u2. N2 we just missed it, no? So keep it N2 into N2
Yeah.
into N2. N1 U1 is equals to N2 U2. No, we just took only dimensional part. We did not take N2
Yes.
part. We forgot this. Now what gets cancelled? This gets cancelled. So 10 is equals to 1 by 4 into N2. So what will be N2 value now? It is
Okay.
40. So this is how you have to deal. Sometimes they will not tell you CGS or MKS. They'll tell you these are the dimensions. Doubled, tripled, halved, divided by 5. What you have to do is take the same dimensions on the right side, but in the place of M, what they have given 2M. In the place of L, L by 2. In the place of T, 2T. And keep it N2 as
Okay.
it is. We will find its value. Okay.
Okay.
Any doubt?
No, ma'am. Clear.
Okay. Dimensional analysis, it will take time. Sahiti, let me know. Morning, when will you be free?
Morning, I'll go to college at 7, ma'am.
Uh, Again, you will come back
At 6:30, between 6 and 6:30.
6 and 6:30. Sunday?
Sunday, free, no classes.
No classes. Okay. So, morning, will it be okay if I take a class for you?
Yeah, ma'am. Okay.
6, 7. You will go to college at 7.
Yeah, ma'am.
Mm, 7 అంటే టైట్ షెడ్యూల్ అయిపోతుంది. Actually, Sahiti, evening class is not sufficient, Sahiti. We need to